Here's something that sounds impossible. Every single human being who has ever lived, no matter what they look like today, descends from ancestors with dark skin. Not some of us, all of us. And here's the part that really breaks people's brains. A man who lived in Britain 10,000 years ago, buried in a cave, DNA fully sequenced by modern scientists, had skin as dark as anyone living in equatorial Africa today. Not tan, not olive. Dark. Pale skin, the thing an entire continent now associates with being European, hadn't even arrived yet. So if every human started dark, and stayed dark for almost the entirety of our history, what actually happened? Why did skin color change at all? Why did it take so unbelievably long? And why did it happen, more than once, in different places, for completely different reasons? Go back about 1 to 2 million years, long before anything you'd recognize as a modern human, and you land on the real starting point. Early hominins in Africa were losing their body hair, evolving millions of sweat glands to cool down while running and hunting in open blistering heat. That left bare skin, exposed directly to brutal equatorial sun for the first time. Natural selection responded fast, in evolutionary terms, by loading that skin with high levels of melanin, the same pigment that darkens skin, hair, and eyes today. Darker skin acted like built-in sunscreen, shielding the body from relentless ultraviolet radiation. This wasn't a cosmetic feature. It was survival equipment, and for the next several 100,000 years, every human ancestor on Earth had it. Here's what dark skin was actually protecting against. Intense UV radiation doesn't just cause sunburn, it destroys folate, a nutrient absolutely critical for cell division, healthy pregnancies, and normal fetal development. Populations exposed to strong equatorial sun without enough melanin faced higher rates of birth defects and reproductive failure, which is about as strong a selection pressure as evolution can apply. On top of that, UV damage to skin cells raised the risk of deadly skin cancers over a lifetime. In a world with no clothing, no sunscreen, and no shelter from the sun for most of the day, dark skin wasn't a preference. It was the only version of skin that let humans survive and reproduce successfully near the equator, which is exactly where our species spent the vast majority of its early existence. Sometime around 70,000 years ago, give or take, groups of humans began leaving Africa and spreading into completely new environments. Southern Europe, Central Asia, eventually the edges of Siberia, places where winters brought short days, weak sunlight, and months of gray skies. The same dark skin that had been essential protection near the equator was now sitting in an environment with barely enough UV radiation to matter. That created a brand new problem, one nobody planned for and nobody could see coming, because it wasn't dangerous immediately. It was dangerous, slowly, quietly, over generations, in a way evolution takes a surprisingly long time to notice and correct. Human skin makes vitamin D using UV light, a nutrient essential for absorbing calcium and building strong bones. Dark skin is fantastic at blocking UV, which is exactly the problem in a low-sun environment. Less UV getting through meant less vitamin D being produced, and chronic vitamin D deficiency causes rickets, weakened bones, pelvic deformities, and serious complications during childbirth. In regions with weak winter sun, a population stuck with high melanin levels would slowly accumulate more birth complications and weaker skeletons generation after generation. Evolution doesn't move on good intentions. It moves on which bodies successfully reproduce, and in low UV regions, that slowly started favoring something new. Here's the twist most people never hear. Lighter skin didn't evolve once and spread everywhere. It evolved independently, multiple separate times, in different populations, using different genetic mutations that landed on a similar result. European populations and East Asian populations both evolved lighter skin, but largely through different genes doing different jobs, arriving at a comparable outcome from two separate evolutionary paths. That's what scientists call convergent evolution, unrelated solutions to the same environmental pressure. It's strong evidence that lighter skin wasn't some single ancient trait waiting to be unlocked. It was invented, essentially from scratch, wherever low sunlight made it worth the trade-off. Now here's the part that upends the timeline most people assume. If humans started leaving Africa around 70,000 years ago, you'd expect skin to lighten almost immediately in low-sun regions. It didn't. Genetic evidence shows the mutations responsible for light skin in Europeans only became common somewhere in the last 5,000 to 8,000 years, a small fraction of the time humans have lived at those latitudes. For tens of thousands of years, humans living in Europe stayed dark-skinned, despite the weak sun, running an actual vitamin D deficit the entire time. Evolution had the pressure. It just took an extraordinarily long time to act on it. This is exactly what Cheddar Man confirmed. Discovered in a cave in Britain, dated to roughly 10,000 years ago, his remains were recent enough for scientists to extract and sequence actual DNA. The results showed dark skin, dark curly hair, and strikingly blue eyes, a combination that looks almost backwards to modern assumptions about who belongs where. Britain, a place now overwhelmingly associated with pale skin, was still populated by dark-skinned people barely 10,000 years ago, which, in evolutionary terms, is essentially yesterday. Pale skin as the norm across northern Europe is a startlingly recent invention, arriving thousands of years after humans had already been living there. So what finally pushed lighter skin from rare mutation to dominant trait? Around the same window, agriculture was spreading across Europe, and diets were shifting hard toward grain-based farming instead of the fish, organ meat, and wild game that naturally contain vitamin D. That removed a dietary backup that had been quietly compensating for weak sunlight for thousands of years. Once that nutritional cushion disappeared, the vitamin D pressure on skin got sharply worse, and lighter-skinned individuals who could produce more vitamin D from the same weak sun suddenly had a real survival and reproductive edge. Farming didn't just change what humans ate. It may have been the final push that made pale skin worth keeping. Step back, and the picture gets strange fast. Skin color, one of the most visually obvious human traits, sits on an incredibly thin, incredibly recent layer of our genetics, changed by a handful of mutations acting on one protein pathway within roughly the last 10,000 years. Meanwhile, the vast majority of human DNA, the traits that make us fundamentally human, was locked in hundreds of thousands of years earlier and is functionally identical across every population on Earth. The most visually obvious difference between human groups turns out to be one of the newest, most superficial adaptations we have, layered on top of something almost entirely shared. This isn't just trivia. Understanding that skin color is a fast, localized adaptation to sunlight explains real modern health patterns, like why populations with roots near the equator face higher risks of vitamin D deficiency in cloudy northern cities, or why very pale skin evolved in low-sun regions carries higher skin cancer risk near the equator today. It also quietly demolishes the idea that skin color reflects any kind of deep biological divide between groups of people. It's a shallow, recent, sun-driven adjustment, not a fundamental line separating humanity into different categories, and the DNA backs that up completely. So every human alive traces back to dark-skinned ancestors, and lighter skin only shows up when you zoom into the last few thousand years, in specific places for one specific reason: not enough sun to make enough vitamin D. It evolved more than once, it evolved shockingly late, and it changed one of the most visible things about us while leaving almost everything else untouched. Skin color was never about identity. It was always just sunlight, geography, and biology working out a very old, very simple problem. Ever wondered what other traits we assume are ancient actually turn out to be this recent?